Physics in computer games have been evolving ever since computer games became a mainstream part of North American life. According to RiverJournalOnline.com, 11.2% of Americans spend 7 to 12 hours a week playing video games. This increase in game popularity has caused the population to sit at their computers a lot more, but has also provided another medium we communicate through on a daily basis. Physics in games today is used in two general ways: to make the player feel more immersed, or to change the way the world works to make the game more fun and interesting. In the first method, game developers try to emulate the real world as much as possible, even using the exact gravity equation that we use in class to determine how things fall. This here is an example of a game that has tried to do that. So here in this scene you can see that the light from the fires is being distributed and bounced off all the materials around it. In games, there's something that we use called bounce lighting and baked lighting, where because light is so complicated to compute, you bake it into the scene. So the computer pre-calculates all of the bounces, and you can do you can choose the number of bounces that you want your light to have, and then it'll figure out how to make the scene look and diffuse the light over an area. There's a lot of different techniques that are used for real-time lighting and static lighting. And then you can see reflections here. That's another big thing. There are things called PBR materials that have 5 different textures. One of the textures is the normal, just the look of it. Another is the normal map, so all the bumps and crevices that show how the shadows will interact with the object. Another, I believe, is specular map, and that provides it's hard to describe, a light, the way it absorbs light. And then the third, I believe it's metallic, and that's how it reflects light. So really, each of these textures here that you're seeing on these little urns have 5 different sets of data on every one of the surfaces about how light is absorbed, reflected, and how shadows are cast and how the thing looks. And then you can see there's a rock there, and then this is another great example with light. You can see they're God rays. In game development we call them God rays when you can see the rays of light through a slate fog coming through this bunch of birds, which is it's quite impressive actually, because you have to do it in real time and you can't really bake and pre-calculate that. And then here there's just great diffusion across the scene. So diffusion is when, and at least as far as I know in game development, the light is shining on an object, but it's sort of spreading out as it shines through, because light behaves as a wave. And then up ahead there's cloth simulation, which is also quite a difficult thing to achieve. So you can see the cloth is behaving more or less how it would in real life. So the second example is where games try to make an entirely new concept that is outside of physics to sort of make a new game mechanic. And a good example of that is Portal 2, where the entire concept of the game is where you have a portal gun and you're just solving puzzles to try to get out of various rooms. And the portal gun can grab things, and it also makes portals that you can hop between. And then other times, games might change the gravity value that we use. And by gravity value, I mean the acceleration that is caused from gravity. So in Mario, they've lowered that acceleration. So on Earth, the acceleration from gravity is 9.8 meters per second down at all times. In Mario, it's probably less than that by quite a significant margin. And I think that's to make the player feel more bouncy and floaty. It's actually a really good way of achieving that. So yeah, I hope you enjoyed this showcase on how physics are used in games. Thank you.